So yesterday we ended, y'all wrote down these steps for if we have two forces that are acting on a single object. To be able to find the overall force, here's what we have to do. We've got to break the forces down into their components. Okay, you can't just add the two amounts together because of the direction aspect of it. So you have to break them down into their components. You add those parts together, like we did yesterday. We added the vectors together to get the resultant force. Find the magnitude. We know how to do that. And then find our direction angle. This is where people mess up all the time, is in step 4. Okay? Finding your direction angle using the inverse tangent. They got that part, but they forget to make sure it's in the correct quadrant. Okay? So that's what I'm going to try and focus on when we're doing this. So example 2 there says that we have two forces, F sub 1 and F sub 2. F sub 1 is 30 pounds. F sub 2 is 10 pounds. They're acting on an object. The direction of F sub 1 is north 20 degrees east, and the direction of F2 is south 65 degrees east. Let's find the magnitude and direction of the resultant force. We're going to round to the nearest tenth. So let's start by drawing ourselves a picture so we can just kind of sketch out what's going on here. So force 1 is north 20 degrees east. So we start at north, we go 20 degrees towards east. This is force 1, and it is 30 pounds. Force 2 is south 65 degrees east. Yes, I know that's not exactly 20 degrees and exactly 65 degrees, but 20 degrees should be closer to the vertical, 65 degrees should be closer to the horizontal. All right, so in order to find the resultant force, we don't just add 30 and 10. Okay, the resultant force is not 40 pounds. Because of the angles. So we've got to break these down into their components. So let's find the component form of force 1. X equals the magnitude 30 times the cosine of what angle? Our angle must always be measured from where? The positive x-axis. 20 degrees is not measured from the positive x-axis. 20 degrees is measured from the vertical. So what do we need to plug in here? 70 degrees. The y component is 30 sine of 70 degrees. All right, 30 cosine 70. Make sure we're in degree mode. 30 sine 70. Okay, that gives us the y. So round to the nearest tenth, let's go at 10.3 and 28.2. Those are the components of force 1. Again, make sure it makes sense. Force 1 is only 20 degrees from north, so it should be more vertical than it is horizontal. The y component is bigger than the x component because it's closer to vertical. Let's do the same thing for force 2. The x is 10 cosine 65? No. What should we put in there? You got two choices. Okay. We can go with negative 25. We can use negative 25. Or if you don't like negative angles, we can add 260 to that. So we could use positive 335. Okay. I prefer just to use the negative, personally. But I'm going to write the y component. There's nothing different about these. Negative 25, 335 are the same angle. I'm just pointing out that it doesn't matter which one you use. Okay? But you don't use 65. Oops. Sorry. So our x is 9.1. Our y is negative 4.2. We're expecting the y coordinate to be negative because we're in the fourth quadrant. Positive x, negative y. We're also expecting to have more horizontal than we do vertical, because this angle is not as far away from the horizontal. It's further away from the vertical. So more x, less y. All right, so we have our component forms. We're going to add our components together to get the resultant. Okay, so let me use purple for the resultant. We've got 10.3 plus 9.1 and 28.2 plus negative 4.2. So that gives us what? 19.4 and 24. So that's the component form of our resultant vector. But we need its magnitude. We need to know what is this actual force. So we've got the x, we got the y. So we square them, we add them together, and take the square root. So the actual force is the square root of 19.4 squared plus 24 squared. So our actual force is 30.9 pounds. Now, before you calculate the angle, I always want you to stop and ask yourself, what quadrant am I in? So what quadrant is the resultant force in? The first. Positive x, positive y. We're in the first quadrant. Guess what? First quadrant means we're not going to have to change anything. Okay, first quadrant means we don't have to change anything. So the angle is the inverse tangent of y over x, 24 over 19.4. So our angle is approximately 51.1 degrees. And approximately 51.1 degrees. Okay, so we didn't have to do anything to that one because that is an angle in the first quadrant. Our resultant force is in the first quadrant. Okay, so it's pulling, and it makes sense. Force 1 is a lot more than force 2, and it's a lot steeper, so it makes sense that we're kind of favoring force 1's side. Okay, because we're in the first quadrant, that's where force 1 is. We're pulling more towards force 1 as opposed to force 2 because it's a greater force and it's a steeper angle there. Okay? So, every single time you break the forces down into their components, add the components together. Once you get this resultant vector, this is all you're going to deal with. You're not going to use any of those other numbers anymore. Okay, once you get the resultant vector, that's all you're going to operate with. You don't go back to those original numbers anymore. Why do I point that out? Because I've had lots of people do that in the past. Okay, once you get the resultant vector, forget everything else. You're only using those results.